Welcome to the CompTIA A+ 220 1101 or Core 1 exam. This is Objective 3.5, Power. In this video, we're going to talk a lot about computer power. But before we do that, I want to make sure that you understand that if you're working inside of your computer, you should always disconnect the power source when you're working on that device. This is non-negotiable and it is best practice. If you hear someone else tell you that it's okay to plug everything in and start taking things apart, they are totally wrong. It's very dangerous to do that. Another challenge you might have is that some components will have capacitors that store power over time. So even when you're unplugged from a power source, those little devices could shock you still. You should always follow the manufacturer's instructions to ensure that all of the power in that device has been dissipated. You should also never connect any part of your body to any part of the electrical system. That includes the electrical ground. Do not connect yourself to any part of the electrical ground system. Electricity flows some very specific rules. And it doesn't care whether you're playing by the rules or not. If you happen to be in the way, then you could get hurt. You should always respect electricity, and it will respect you. Your computer motherboard and components commonly use direct current to provide power, or we say DC power. But your power sources are receiving alternate current, or AC power, from the power outlet. So that means that we'll need to do some type of conversion between alternating current and direct current. One way you would do that is through the power supply of your computer, which converts that input of AC power to provide an output of DC power. And it's very common for these power supplies to provide 3.3 volts and 5 volts and 12 volts of DC power. We often say that this is the most important component inside of your system because of your power supply isn't working. Well, then nothing's going to work. So it's very essential and vital. I love this picture, and I've seen different people explain amperages and volts in different ways. Think of amperages as a flow of an electron or a flow of water. It's similar of electricity going down a wire as we would compare it as water going out of a hose. And if you have a larger diameter hose able to support a larger number of amps, it can hold more. Another important measurement is voltage. This is sometimes abbreviated as volt or capital V. This is referring to how much force is pushing through. So if you were to turn the knob on the water and push more out, that would be voltage. And that is considered the pressure of how fast it moves and how intense it is, versus the amperage, which is more of the flow and how much will go down the hose. If you start looking at power supplies that are used on computers, they're often rated by the number of watts. A watt is a measurement of real power used for that power system, and it's often abbreviated with a capital W. If you wanted to calculate the number of watts that would be used, you would take the volts that are in use, multiply it by the number of amps to have the total number of watts. So if you're using 120 volt power with a device that uses 0.5 amps, then you have a total measurement of 60 watts of real power use. Alternating current is abbreviated as AC. And as I mentioned, this is the type of power that we need from an outlet that's in the wall. We're commonly distributing power using alternating current to be set over very long distances. The reason why we call it alternating current is that the direction of the current is constantly alternating between one direction and another. We often refer to the number of times this current alternates as a total number of cycles or hertz. It's very common in the US to see 110 to 120 volts of alternating current. and it's alternating at a rate of 60 times a second or 60 hertz. In Europe, you'll commonly find 220 to 240 volts of alternating current coming from your wall outlet, and it's commonly used at 50 hertz frequency. Well, if alternating current is going into our power supply, then direct current, or DC, is what's coming out of our power supply and onto the motherboard. With direct current, we don't have to worry about going back and forth. As the name implies, it's just moving in one way. With all these differences in power systems, if we take a computer from one country and move it to another, we'll want to be sure that the power supply is able to support these changes in voltages. As we mentioned earlier, in the US, it'd be 120 volts of AC running at 60 hertz frequency. In Europe, it would be 230 volts AC at 50 hertz frequency. Your power supply may have a switch that allows you to change it between those 2 volts. If you're not exactly sure what's coming out of your outlet, you can use a multimeter to measure it. If you're not using an auto switching power supply, then you want to be very careful. You do not want to plug in a manually switched 120 volt power supply into a 230. You're going to see sparks fly if that happens. Another characteristic of direct voltage is that we specify it as either a positive or negative value. The voltage is the difference in the electrical potential as compared to the electrical ground, and where you measure from becomes very important. If you think about standing in front door of your house, the second story of your house is 10 feet away from you. But since that is above you, we often refer to that as being plus 10 feet. The basement of your house would be 10 feet even more below you, so you could use a negative number to measure where it is. Higher voltages are commonly associated with components inside of your system that need additional power. I tried to simplify this as much as I could in one slide, but it is a lot of information. So let's take a look at it right here. Let me get my pointer. Okay, so larger 12 volts would be probably for motherboards, PCI adapters, larger components. Okay, plus 5 volt. Some sort of motherboard components may use a little bit more electricity, so they would use 5 volts. But more commonly we see is 3.3 volts, such as an M.2 slot, maybe the RAM that we use, different circuits to the motherboard. Plus 5 is just for standby, and then down here, negative voltages you can see on integrated ports, maybe like LANs or older cards. And negative 5 volt is for an older ISA motherboard type, which is not on the exam, so it's not very common. So don't worry about that. Okay, we're at the end of the objective here. What voltage does an M.2 drive require? And this was a trick question upon myself because I found different answers on the internet. Okay. Consider the size and take your best guess. Is it A, plus 12 volt or plus 5 volt? B, plus 5 volt or plus 3.3 volt? C, 3.3 or plus 12 volt? Or D, negative 12 or negative 5 volt? We did just see in the slide that most M.2 take 3.3 volts, but I see that some of the larger ones, especially on desktops, can take up to 5 voltages. Thank you for watching.